study of polynomials. We're going to be looking today at how to write an equation for a polynomial function from its graph. So we're going to be going backwards from what we just learned on how to graph from the equation. So it's actually a very intuitive piece. If you follow along, we'll go ahead and get started. I'm going to refresh our memories on how to graph a polynomial from factored form. You need to determine the zeros of the function, which is also the x-intercepts, another name for that. While you're doing that, you need to include any multiplicities, because the even multiplicities, you recall, is a bouncing x-intercept, and the odd multiplicities creates a cubic-like curve through the x-axis. You're also going to find the y-intercept. You're going to determine the end behavior from the degree and the leading coefficient. And then you're going to sketch a graph from your information. So here is a possible example. We have x minus 1 times x plus 2 squared times x minus 4. The zeros are relatively easy. It's whatever makes these factors 0, right? This thing in the parentheses, by the way, is called a factor. If we plugged in x equals 1, we're going to get a 0. If we plug in x equals 4, we're going to get 0 for here. And if we plugged in x equals negative 2, we're going to get a 0 in the middle factor, but it has a multiplicity of 2, which graphically means it's going to bounce, obviously. And if you get the y-intercept, that's when you plug in x equals 0. You're going to get negative 1 times 2 squared times negative 4. So negative 1 times negative 4 is positive 4. 2 squared is 4, so 4 times 4 is 16. So we're going to go ahead and look at the sketch of this graph. So I need to go to negative 2 and positive 4. And somewhere up here is positive 16. We're going to have a 0 at negative 2. We're going to have a 0 at 1, or in other words, x-intercepts, by the way, and an x-intercept at positive 4. Now, this is a 4th degree polynomial because there's 1, 2, 3, 4 x's in here, and if you were to multiply, you would have x to the 4th power. And all of those x's are positive, so it's a positive 4th degree polynomial. I think I wrote that here somewhere. There we go. The leading coefficient is positive and the degree is 4, so that means my end behavior is going to go up on the left and up on the right, because even degrees go in the same direction and positive even degrees go up, up. So we're going to go and we're going to bounce off of negative 2. We're going to come up here and cross through 16, and then we're going to go through positive 1 and through positive 4. So here we go. We're going to do our best to bounce off of negative 2. Oops, that's not a very good line in my book. So here we go. We're going to bounce off of negative 2. We're going to come up here and go such a way so we can come straight down to 1 and straight up here to 4. And there we go. We have a sketch of the graph. Now, you remember what we just did. We found zeros from the factored form. And really, to go backwards is to go the other direction here. We're going to find the zeros and then make the factors for our polynomial. All right, so let's take a look at what we are going to do here. So, how to write polynomial function. First, we are going to write the factors, and we're just going to basically determine the x-intercepts, or the zeros of the function, and we're going to write the factors that they represent, including any multiplicities that might occur. For the most part, all we're ever going to get are x to the first, x to the second, or x to the third. So we're going to get multiplicities of 1, 2, or 3. Second, I'm going to call the compensation step. We're going to multiply the front of the equation by a number to make the y-intercept and or the end behavior correct, if necessary. Okay, so put in there, because I did not type it in, put in there, if necessary. It's not always the case. You don't always need to multiply. So that really is the steps on the how-to. So let's take a look at what it's going to look like. So here we have a polynomial graphed. I know it's going to be an odd degree because it starts down on the left and up on the right. So I'm just going to make a note. I'm going to look at this and I'm going to go, okay, here's my zeros. Oops. Let's do, there's a 0, there's a 0, there's a 0. Those are my three x-intercepts, and there is my y-intercept. So I have x-intercepts at x equals -2, +3, and +4. And that makes 3 zeros, which makes sense for an odd degree. This -2 goes straight through, as does 3 and 4, which means it's going to be multiplicities of just 1. So we don't have any repeated zeros here. And so what I do first is I write just the given factors. So if I use -2, that means it has to be x plus 2. If it's +3, that means it had to be x minus 3, and likewise for 4, so x minus 4. So that's my first guess to the equation. So then I need to do, what is f of 0? Because I have to check. If I get f of 0, here I'm going to get 2 times -3 by plugging in 0 for x, and -4. -4 times 3 is 12, and times 2 is 24. Well, that means my y-intercept will come out correct. And because it's a positive leading coefficient, it should start down and end up. So we make that note like I just did. We're going to note that the y-intercept 0, 24 is correct. So there is no need to compensate, and the original attempt is correct. So this is the equation to this graph. All right, so let's try that again. We have a couple more examples here to deal with. Example number 2 looks like this. Notice we have a bouncing 0 in this case, which means we're going to have a multiplicity on this example. So I'm going to make a note of all 3 of my y-intercepts, or sorry, my 3 x-intercepts and my 1 y-intercept. And we're going to take a look. We know that I have -2. I have 1 with a multiplicity of 2 because it bounces, so I have an even multiplicity. And x equals 2 just happens once. You also should make a note, obviously, that the y-intercept is 0, 8. So with these 3 zeros, I need to first just write my initial guess. And my initial guess is based off of these 3 zeros. So for -2, it's x plus 2. For +1, it's x minus 1. But since there's 2 of them, I have to square it. And for x minus 2 for the +2 here. Now, there's an issue on this problem. This thing that is written is a positive 4th degree polynomial. So that should go up, up. But we notice this one goes down and down. So we need to change the sign. And also, when I find the y-intercept, when I plug in x equals 0 to my original equation, or my first guess, I get -4. Because we get 2 times -1 squared times -2, which means -4. But that's not right because my y-intercept is actually +8. So we know that the end behavior is the wrong direction and the y-intercept is in the wrong direction. But if we multiplied by a negative number, we could make the end behavior correct. So we could just put a negative in front, and that would make the end behavior correct. But then my y-intercept would be a positive 4, where I want a positive 8. Well, it's easy to make a 4 into an 8 by simply multiplying by 2. So if we were to multiply by a negative 2 in the front of my equation, we would get the correct equation, and that's all we're going to do there. We're going to multiply the entire equation by negative 2 in the front. Now we get the correct y-intercept, we get the correct end behavior, and we still get the same x-intercepts because we did not change any of that. All right, so just remember what we just did. I want you guys to really know what we just did here. So we had the 3 zeros, we took care of multiplicity, and then we went through a couple of notes. We wanted to make sure our y-intercept was correct, but it wasn't. It should have been a positive 8 rather than a negative 4. So if we multiplied everything by a negative 2, we got the correct y-intercept, we got the correct end behavior, and we get the correct equation. One last example here is an example, very important example, because I want you guys to see what a multiplicity of 3 looks like. So if we were to look at the zeros, we notice that the end behavior is up, up, so it has to be an even degree. My y-intercept is negative 8, and let's take a look at what that is going to mean for us. So we have zeros of negative 2 and positive 2. Here is where you really need to look to see what a multiplicity 3 looks like. Notice the squiggle that goes through at negative 2. Notice it doesn't go straight through, but it does a little bit of a curve at negative 2. So that's why I know it's a multiplicity of 3. So we write our initial guess. We say x plus 2 and x minus 2 to the third power for the multiplicity. Then we do our little notes. We need to note, from our guess, the y-intercept is negative 16. But it's supposed to be negative 8. Well, again, it's very easy to change a 16 into an 8 by cutting it in half. So what we do is we just simply multiply by 1/2 to get the correct equation, and we get this. We just put the 1/2 in front of our two factors, and we get a final answer. All right, so that is actually it. That finishes it off for this lesson. You'll notice what's coming up next is long and synthetic division of polynomials, but that is in lesson 6. Lesson 5 is a no notes video, but there will be some more interesting things. All right, I will see you guys tomorrow. Hope you learned something today.